that we have full control of the physics. We understand what's happening. But there is a fundamental clash between our two basic theories of nature. It's one of the strangest and most fascinating questions in all of modern space science. What really lies inside a black hole? We've never been able to peek inside one. And by their very nature, we may never be able to. Yet, some physicists believe the answer isn't just mind-blowing. It might be us. Yes, a growing number of scientists think that our entire universe may have been born inside a black hole. And recently, data from the James Webb Space Telescope added unexpected support to this radical idea. So, how could that be possible? After all, black holes are thought to destroy anything that falls into them. Or do they stick around until the end? Because if this theory is right, then you might just be inside a black hole right now. The universe is the ultimate creator of extremes, crafting some of the most hostile, chaotic, and mind-bending environments known to science. One of its most powerful creations, black holes. These gravitational monsters are so powerful that they trap everything that comes too close, including light itself. And yet, not all black holes are the same. At the smaller end, we have stellar black holes formed when massive stars run out of fuel. The outer layers of the star explode in a supernova while the core collapses inward under its own gravity. These black holes typically weigh a few times the mass of our Sun. But on the other end of the cosmic scale, we find supermassive black holes, millions or even billions of times more massive than our Sun. These behemoths anchor the centers of nearly every large galaxy, including our own. At the heart of the Milky Way lies one such object, Sagittarius A*, weighing in at about 4.3 million solar masses. Now, how supermassive black holes form remains a mystery. Some theories suggest they grew over time from smaller black holes merging, while others think they formed directly from collapsing gas clouds in the early universe. One thing is clear, though, they leave a massive imprint on their surroundings. Supermassive black holes can actually help shape entire galaxies, and their powerful jets are what drive quasars, some of the brightest objects in the cosmos. And although black holes are infamous for their destructive potential, they don't automatically destroy everything around them. Outside their event horizon, the point of no return, black holes behave like any massive object. Stars, planets, and even entire solar systems can orbit them safely as long as they don't get too close. But what happens if something does cross the event horizon? That's where things get wild. Inside a black hole, space and time behave completely differently. According to general relativity, all the matter falling in gets compressed into singularity, a point where gravity becomes infinite and space-time, as we understand it, breaks down. The problem: physics can't currently describe what actually happens at this point. Our equations just stop working. Theories like Einstein's general relativity simply don't apply under these extreme conditions. And no, we can't send a probe in to find out more. Not only would it be destroyed, but any information it gathered could never escape the black hole to be sent back. That's why scientists have to rely on theoretical models. And one of the most fascinating ideas is this: maybe what lies inside a black hole is a new universe. Some models propose that instead of a true singularity, there's a cosmic seed, a point where all the energy and matter reaches a maximum density, then rebounds in a kind of reverse Big Bang. This explosive birth could create an entirely new cosmos separate from our own. And that leads to a mind-bending possibility, that our own universe was born from the collapse of a black hole in a parent universe. This isn't just a wild idea. Some theories, like Schwarzschild cosmology, are supported mathematically. In this framework, each black hole gives birth to a baby universe inside it, cut off from its parent universe by the event horizon. And here's where things get even more interesting. A team of researchers analyzing data from the James Webb Space Telescope might have found observational evidence supporting this theory. Led by Leah Shamir of Kansas State University, the team looked at more than 260 early galaxies captured in a deep field image by JWST. What they noticed shocked them: a strange imbalance in the rotation of these galaxies. Around 2/3 of the galaxies appeared to rotate clockwise while only 1/3 rotated in the opposite direction. That's not what you'd expect in a random universe. In a truly random cosmos, the spin of galaxies should be evenly distributed, half one way, half the other. But the rotation bias suggests something else: an initial spin or momentum potentially inherited from the black hole that birthed our universe. If the black hole that created our universe had angular momentum, meaning it was spinning, then it could have passed on that spin to the matter inside it, influencing how galaxies formed and rotated. This discovery adds weight to the idea that our universe could exist within a black hole in a larger parent universe. Each black hole in that cosmos could be the seed of a new universe like ours. And each of those universes might spawn even more. Think of it as an infinite multiverse, with black holes acting as the portals between generations of reality. Of course, this is still just a theory, but it's a theory that's gaining more and more attention as our observational tools become more advanced. The fact that James Webb has already turned up something this weird so early in its mission is a sign that we might be closer to answers than ever before. So, are we living in a black hole? We don't know for sure, but the idea is no longer just science fiction. It's a serious hypothesis supported by both physics and now possibly evidence. And if it turns out to be true, that would mean every black hole could be a universe of its own, and we might just be inside one looking out. If it turns out to be true, that would mean every black hole could be a universe of its own, and we might just be inside one looking out. That possibility isn't just awe-inspiring. It fundamentally changes how we think about the cosmos, our place within it, and what we define as reality. For centuries, humans have looked to the stars and asked, where did we come from? The idea that we originated from inside a black hole reframes that question in dramatic fashion. It suggests that the Big Bang wasn't the beginning of everything, but rather, a transition, a continuation, or even a birth inside a larger and older realm. This concept blends physics with philosophy. If every black hole births a new universe, and that universe can in turn produce black holes that form their own baby universes, then we might be part of a vast generational tree of cosmic evolution. In this structure, universes beget universes. What's more, this cosmic tree could be infinite in depth and reach, implying not just a multiverse, but an evolutionary system where universes themselves are subject to natural selection. Some physicists, like Lee Smolin, have even proposed that the physical constants of nature, like the strength of gravity or the masses of fundamental particles, might vary slightly from one universe to another, and those universes that produce more black holes go on to reproduce more effectively. It's a radical take on evolution applied not to biology, but to cosmology. Just as certain traits help living creatures thrive and pass on their genes, certain physical parameters might help universes survive by maximizing black hole production. The implication? Our universe might be tuned not for life, but for black hole creation, and life could simply be a byproduct of those physical settings. This theory is known as cosmological natural selection, and while it remains speculative, it offers a framework for why the universe appears so precisely fine-tuned for complexity, structure, and longevity. The implications deepen when you consider what this means for time and causality. If our universe originated from a black hole in another universe, then perhaps time flows differently in that parent realm. Our sense of before and after might be confined to the bubble of our own cosmos. In the larger framework, causality itself may loop or fragment. What we think of as the beginning could be merely a local event in an ongoing tapestry of creation. It also raises haunting questions about what lies beyond our universe. If we are inside a black hole, then outside our observable cosmos is not simply void or empty space, it's the interior of some higher dimensional black hole structure. And just like we can't see past our own event horizon, we may never know what exists in the parent universe. We are cut off, isolated, and perhaps fundamentally unable to access that external reality. This makes our cosmos a kind of cosmic womb, self-contained and self-evolving. But how do scientists even begin to test such ideas? After all, we can't step outside the universe to get a better look. That's where tools like the James Webb Space Telescope come in. Its ability to look farther and deeper into space, and therefore further back in time, is offering humanity its first detailed glimpses of the early universe, just a few 100 million years after the Big Bang. The peculiar rotation bias observed in early galaxies may be one such clue. Others could come from subtle asymmetries in the cosmic microwave background, gravitational wave signatures from ancient black hole mergers, or patterns in the distribution of galaxies across vast cosmic scales. Even the very structure of space-time might carry fingerprints of its origin. Quantum gravity, an area of physics still under development, aims to reconcile Einstein's general relativity with quantum mechanics. One approach, known as loop quantum gravity, suggests that spacetime is not continuous but composed of tiny, discrete loops, like a woven fabric. If our universe came from a black hole, then perhaps those loops were twisted or knotted in a particular way during birth, leaving behind a detectable structure that we might someday decode. Another avenue of exploration involves studying the thermodynamics of black holes. Physicists Jacob Bekenstein and Stephen Hawking famously discovered that black holes have entropy and temperature, suggesting that they are not merely voids, but thermodynamic systems with internal states. That insight gave rise to the holographic principle, the idea that all the information within a volume of space can be described by data encoded on its boundary. If that's true for black holes, and we are in one, then perhaps everything we observe in the universe is a holographic projection of data stored on the inner surface of an event horizon beyond our reach. This line of thinking leads to the controversial idea that our reality may be fundamentally holographic. What we perceive as three-dimensional space could be an emergent illusion, arising from two-dimensional information encoded elsewhere. The black hole model adds weight to this, suggesting that the universe itself might be a kind of hologram projected from a higher dimensional surface. And if black holes spawn new universes, what happens to time inside them? Some theories suggest that time could be born at the moment of bounce, the rebound from singularity to expansion. If so, each universe would have its own internal clock, beginning at its own moment of creation. This would decouple timelines between universes, making it impossible to say whether one universe is older than another in any absolute sense. Each cosmos might exist in its own frame of reference, making comparisons meaningless. Still, while such models are bold, they remain unproven. Critics argue that without testable predictions, these theories border on metaphysics. But that's changing. As instruments like JWST, LIGO, and the upcoming Einstein telescope push the frontier